You can't solve this right now, da. You have not done coordination compounds chapter, na?
Sir, I mean, I got the answer. I don't think.
I've started doing guess over here, but the problem is guesswork is not enough.
Is it in the solution they said something about ligand and stuff? I didn't understand
Yes, that's
exactly.
the point. Guesswork is not enough.
Okay.
You can only take educated guesses here, it will not work fully.
Okay.
So for instance, in this particular case here, they have given you three complexes. First one here, and you're having these three, right?
Hmm.
Now
Yeah.
they're asking you to rank them according to their spin only magnetic moment values. Now you need to know what ions they are first, that you can guess over here.
Yeah.
In
That's
this case, this is going to be
Fe3 minus.
ion plus 3 here. Here this has to be an vanadium plus 2. This guy has to be an ion plus 2.
Yeah.
These three are easy enough to basically get. But the
Hmm.
situation here is not that simple. You'll have certain complexities attached with respect to what is going to be happening when the, how to say, complex is actually formed. For example, if I'm going to be having, say, ion plus 3 or ion plus 2 is a better case actually. If I take ion plus 2, what is the general electronic configuration for it?
4s2. 4s2. Sorry, no. 4s2. 3d 6.
So ion atom is 4s2 3d6. So ion
3d6.
plus 2 becomes 4s0 3d6.
Hmm.
Right. Thing here is, if this is 4s0 3d6, how do we basically end up tracking what is meant by 4s0 3d6 here? 4s0 3d6 here is basically going to be something which can have different configurations. I can have it like this. 6 electrons like this, or in certain other cases where we are going to be having a ligand, or when you're going to be having the coordination complex forming. When the coordination complex is formed, what happens is these 5 orbitals, instead of being degenerate, can actually split into two different levels. In fact, they always split into two different levels there, and you will have a possibility of the entire thing becoming like this. That is, a 3d6 can be like this completely. As you can quite clearly see, in the first case here, we are going to be having 4 unpaired electrons. Whereas in the second case here, we are going to be having 0, which means the spin will be 0 as well here.
Hmm.
That's the idea.
So this happens in p orbitals as well.
No, this does not happen for p orbitals. It only happens for d orbitals, and we are not going to be going into why this happens. That's a much more complicated situation, which you'll learn in a completely different chapter.
Hmm.
So this is where your problem probably showed up. Somewhere in one of the options, they would have given you something unexpected.
Yeah, and the solution. I mean, I got the right answer somehow, but like when I
If you
was
got
going
the
through
correct
this,
answer, then let's not go there. Just be happy that it's something acceptable. What was your answer here?
it was p greater than r greater than q.
Which is P greater than
R greater than q.
So you basically just bluntly did the answer there, right?
Yeah.
And you got lucky based on that. So let it
So
be good enough that you got lucky. That means here there is nothing which is going to be taking part here. The reason why nothing is happening is because all of them are in
weak.
this configuration, this
Okay.
type of situation. None of them go to this one. This doesn't happen. So only
Hmm.
this is going to be happening mainly because all of these coordination complexes are formed with weak fellows. So let's not go
Okay.
into that. You don't need to worry about that part here. So in this case here, all you had to do was a normal thing. Your answer was fine because every one of them was going to the same type of configuration. Normal D5 without any funny business happening there.
Hmm.
Okay, next up, how much of your PYQs have you managed to cover so far,
So like some 30-ish questions are done.
percentage wise?
They're like almost like 115 here, 190.
And why are you sitting and solving every one of them?
Like the initial one I was doing because they're recent. Like I've done till 2023, I guess. Like, now I'll like start going
You
selectively.
have to up your pace. We'll keep the session today short. I'm not going to be discussing any thermo today. Continue on your PYQ, collect more questions, finish your doubts though first.
Yes, sir. Sir, I don't have anything else.
You're done with your doubts then.
Yes, sir. There are not too many.
There are not too many.
Sir, should I do advanced PVQ as well after this?
Yes,
Okay.
you've just been doing JEE mains PYQ still now, is it?
Yes, sir. I mean, I've done my class questions as well. They were, I think, most of them were PVQs as well.
When you're doing a topic fully and wiping it out, I would recommend that what to say, you do whatever is available in your advanced PYQs and your internal exams questions also.
Hmm.
Internal exam का जो भी question paper लिखा है उसका भी एक बार देख लो. That will also be very useful.
Yes, sir. I've done the questions in my sales notes as well. So most of them like similar to the weekend test paper.
Fair enough. Um, Thermodynamics, then I suppose we can touch upon it again. So you're done with your doubts till now.
Yes, sir. Oh, sir. I had like one conceptual doubt.
Yeah.
Like the sir, you what is in phase and out phase? What does that exactly mean?
Louder, please.
In phase and out phase.
In phase and out of phase.
Yeah. What does that exactly mean?
Let's say I'm going to be having an electron revolving around the nucleus.
Hmm.
Okay. So if the electron is revolving around the nucleus, now according to de Broglie's analysis, the electron should be considered as a wave.
Wave. Hmm.
Correct. So if the electron is to be considered as a wave, the electron can basically revolve around the nucleus like this. So when the electron is revolving around the nucleus like this, from here to here can be considered as one wavelength, lambda. From here to here can also be considered as one more wavelength, lambda. And from here to here, that will be the other wavelength, lambda.
Hmm.
So we technically have three lambdas basically covering the revolution of the electron around the nucleus. In this case here, I have made sure that the electron is starting and ending at the same point as a wave.
Hmm.
This is basically what is referred to as in phase.
Okay.
That is when your electron is basically only ever capable of performing any sort of, if it does perform an interference with itself, it will only be in phase and it will be only constructive type. But if I ended up having a revolution like this, what is happening here? It is not in phase here.
Hmm. It's not. Okay.
So it will basically go like this next, right?
Is a retrace exact path.
Yes. So this is going to be what is referred to as an out of phase type of situation. In this case here, when it is out of phase, what happens when it is out of phase is that it is going to be something which will be absolutely destructively interfering with itself. which means this is not really a possible case because the electron does exist. It doesn't cancel itself out. So
Okay.
that's basically what is meant by out of phase and in phase, effectively. And when you're going to be considering the electron as a wave, only condition which is allowed is going to be your in phase condition, mathematically speaking. So if this is the only condition which is going to be allowed here, what does that lead to? That leads to, in this particular case here, which we are having a look at over here for this one here, what you can see here is that we are going to be having 3 times lambda being equal to 2 pi r,
Super.
right?
Hmm.
That will basically end up leading to, in this particular case here, if we are what to say adjusting things effectively here, what will happen is lambda can be written as what?
H by mb.
Because electron's wavelength, basically electron considered as a wave, so this can be written as 3 into h by
H
mv being equal to 2 pi r.
in h by 2 pi.
Obviously we'll end up getting it in terms of h by a, so we'll end up getting finally mvr working out as 3 into h by 2 pi.
Hmm. Yeah.
Basically indicates that it is in the third shell.
Yes, sir.
That's the idea here.
Yeah.
Clear so far?
Yes, sir. Yeah.
Okay. Next out, what else do you have as a doubt?
Sir, when we have like a like sample of like excited species, and then like where they're like come back to ground state, we consider all the possible cases, right? Like if we had only one, let's say like one hydrogen atom,
Mhm.
then it can only perform like one step at a time, right? Like
Yes.
so when they say sample, you have to assume that all the possible transitions could happen.
Yes, of course. Because you're going to be having more than one hydrogen atom, you're having a large number of atoms. And in all of those atoms, it is at that highest level. So from there, it will basically fall into any possible pathway, any and every pathway,
Hmm.
which it can fall as it is falling down to ground state.
Okay. Yeah.
You understood what you wanted there?
Yes, sir. Yeah.
Okay.
Hmm.
Next up,
Hmm.
there are some interesting, tricky questions which can be asked. For instance, try out the following. Let's say the electron is falling from, say, n equal to 8 to n equal to 2. Okay. This is one case. Second case is it falls from n equal to 8 to n equal to 2, but it skips n equal to 5.
Number of possible cases.
Yeah, have a number
Again,
of possible lines, of course.
spectral lines. Yeah.
And let's say it's going to be skipping in the next case here, n equal to 4 instead of n equal to 5. Same case, n equal to 8 to n equal to 2, it skips n equal to 5 in one case, it skips n equal to 4 in another case.
Sir, only one atom or like sample of atom?
Sample of atoms.
Mm.
The next one is going to be a little bit more interesting. Maximum lines from n equal to 6 to n equal to 1. Subcase 1, only one atom is present.
Hmm.
Subcase 2, two atoms are present. And the fifth question, n equal to 7 to n equal to 1. The question goes like this. To see all the lines, how many minimum atoms? needed. That's the idea here. How many minimum atoms are required over here? Calculate. You can try these out today sometime. Any other doubts you have? Theory, non-theory, whatever.
No, sir. I don't have anything.
Confirm.
Yes, sir. Yeah.
Okay. Do you want to continue with a little bit of thermodynamics, or do we close the session?
I'm fine with anything, sir.